Hi, good evening. My name is Gina Pradovitz. To explain a little bit, I am I'm the president of the AI Chicago Foundation, and the foundation. My job today is to make sure that you leave today knowing what the AI Chicago Foundation does. So what we do is we are the independent not-for-profit charitable organization dedicated to supporting activities across the Chicago area community. Thank you so much tonight for coming to this event, as well as thank you for Design Museum for hosting this event. AI Chicago Foundation supports many projects from architecture education in Chicago public schools into competition and scholarships for architecture students. Tonight, we are pleased to present Anthony Viola, the winner of the 2017 Dubie Family Architect Award. This award is given each year to Chicago architects between the age of 25 and 39 to recognize the excellence in the early career years. Anthony has also received an AIA National Young Architect Award for 2018, so congratulations. Anthony is the senior designer and team leader at Adrian Smith and Gordon Architecture. He works on high performance projects and advanced computational research. Let's welcome Anthony and learn more about what he does.
Great, thank you. Just a few words of thank you to a lot of people, the Dubin family for endowing this award. It's been really humbling and embarrassing winning this award and the national award, and thank you guys for making that embarrassing. The AIA Chicago Foundation, thank you for making the selection, and a special thank you to lifetime mentors for your constant support. And then there's 60% ESGG people here, so thanks for thanks for the support. So the Dubin family, young, not so young, not old, hopefully architect. I just turned 40 last week, and so that automatically disqualifies me now to be the Dubin Family Award winner. So, I just wanted to say a few words about the award submission first. Joan made this crazy charge of make a presentation about basically from birth to now and how you got to where you are now. What influences you had, it was completely great because it takes you away from a presentation that you may have seen about the work, and it just tries to make larger context and give you guys an idea of what sort of interests me. So we'll talk a little bit about my education and projects that I hadn't looked at for 20 years, and then 15 years, and then we'll talk about professional experience, and then hopefully you guys will ask questions and kind of break the awkwardness. So anytime you guys want to have a question, just shout it out, and then it'd be good to have a little chat afterwards about questions that you have. So the submission itself, I would say to anybody thinking about putting it together, do it. I'm not the person necessarily that would normally do this, and there was a moment of I have 10 minutes free, I could lift my head up at work, and I think that this would be a really good thing to just sort of look back at projects that I had done and put something together, and that whole experience is really worthwhile. It really gives you kind of a good look back. And I was doing it in the last year of availability, and actually having been at ASGP for about 10 years, so it was the right moment to do it. The really kind of other crazy thing about putting the submission together is that you have to ask for letters of reference and ask people what they thought about the working relationship you have or personal relationships. And I think overwhelmingly it was just an experience that I didn't expect. I didn't really realize the sort of influence or the influence that I've had on people that I've worked with or that have mentored me or taught me or collaborated with. So that was, you really get a good view of it. And then the other good thing is that it forced you to edit and look at the projects that you've done, look at the part that you've actually contributed and what it means to a total submission. So like the most important things that I worked on or that I helped on the project we'll look at today, at least for the projects of the submission. We'll kind of go back in some fun history that Joan wanted. So it's a great experience. The other thing that, advice that I'll give that I think was important to me to showcase in this submission was sort of the like outside professional activities that I feel very passionate about. So I was the co-coordinator for the design KC, and that was really born out of like this, the sort of want to expose other design professionals, the sort of interdisciplinary design teams that I was getting exposed to at ASGG. The projects are not necessarily always a singular vision. It's a team of a lot of people, and I think that was to me the sort of my avenue towards the design KC. And then that born into like a broader group it's called the Chicago Computation Group, that is just more about advancing how are we engaging technology in sort of broad sense in the design of buildings. So I was born in 1978. Again, my birthday was last week, so it's this is a whole midlife thing. This is a picture from when I was 10 years old. This is a picture when I was 20 years old. I graduated with a Bachelor of Science in Architecture from University of Wisconsin-Milwaukee in 2000, and then a Master in Architecture from University of Virginia in 2005. This is when I was 30 years old. So now you get the 40-year-old. I worked right out of school for a small firm called Future Cities Lab, which will see the work. And then I relocated back to Chicago and worked at Valeria Dwell Training in town for about 2 years. And then I've been at Adrian Smith Gordon Gill Architecture for the past almost 10 years. So just a little bit about childhood. My parents were both teachers. My dad was a science teacher. My mother was an art teacher. And I think that had a big impact on how I learn and how I teach other people. And they had a lot of patience. And they also, my dad had done like handyman jobs during the summer, and he always had just like a sort of array of scrap wood and scrap materials that were just that were more important than maybe other like structured building materials, and it made you like kind of ad hoc create the environment. So actually, the image on the right is not the first computer, but it's indicative of my first computer, which was just a cardboard box. And then this is actually the first computer, and I think it's just funny. It was when I was 10 that we had it in the house, and it's as you'll see in the work, it's obviously impactful. Kind of about where I'm from, Kenosha is sort of an industrial town just north of here, and there's nothing really like remarkably beautiful about it, maybe except for, say, the lake and a couple key things that we'll look at here. But what I found really kind of interesting is the way that there are a lot of factories, or there were a lot of factories in Kenosha, and those factories were embedded in the community. They were like literally across the street from this factory were houses, and not far from where I live. And I think that had a big impact because it was a piece of social infrastructure that wasn't apparent when I was 10 and riding my bike around here, but it is apparent, and you see it. Another kind of unique thing about Kenosha and this idea of pieces of social infrastructure, this is like a pair of beach houses that were built in Kenosha along the lake during the Depression, and these were like works progress administration projects that employed architects to demolish existing buildings that were condemned and rebuild them into public beach houses. So this is sort of an interesting parallel, because now they're going through another period of they'll probably get demolished and rebuilt into something else. Okay, so now we're going to go way back. This is first studios in undergrad, so this is kind of funny, but it was really good to kind of understand the context of this kind of stuff. So this is, say, from 1999. It's a digital design studio, and it was the first one, or the first series of design studios at UWM that were just use the computer in a way that's not drafting and not as a tool, right? How do you engage with it? What is it going to afford you that other tools will not? And this is at a time when there were no other digital design studios. We were taught hand drafting, ink on mylar. Oh, you can just see this was a library project for Milwaukee. Another project from Milwaukee actually was with Neil Frankel. It was a design research studio, and the kind of interesting thing with it was you had to write in a design studio. You had to think and do research and confront issues like how does design impact, in this case, creativity. And so it was just evaluate the program, challenge the conditions that you're given, and that idea of challenging what the status quo and making sure that what you're doing really has meaning that's beyond the image or the line or the wall. Really, had an impact, and you'll see, I think, as you get further in my career, that makes sense. So, these are just early stuff. And I was always going back and forth between this idea of physical models and the digital. Projects at the University of Virginia. When I came out of undergrad, I really felt that I would go to a all digital school like Columbia or SciArc at the time. Was just that's what I'm going to do. And I applied to University of Virginia and visited, and just kind of felt different about how their attitude about making is different than a purely digital workflow. And it has a more, just sort of open pedagogy. And you were challenged to make things in different ways and ways that you hadn't before. So these are just some watercolors from that project. And I think, it just was a different way, again, of making and collaging and using that as a medium to design different things. And all the while I was still, conscious or using digital tools. It just was, you're engaging them in a different way. How are they part of the dialogue, and how is that dialogue bigger? This was another project from the University of Virginia, which was just it was for the New York City 2020 Olympic bid, and this is like the Olympic Village that's along where basically Manhattan meets the Bronx. And it was a much more challenging project because it was a huge swath of land. The Virginia has a very strong landscape program, so this was actually like, how do you design? Nobody at the school was doing kind of density, which is like taller buildings, but then they also were, but they were very concerned about the ground plane. And it was the first time that I had kind of looked at how buildings are framing environments, and how they touch the ground plane is actually really important. So these were just studies of how the tower meets the ground and how the thickened layer of the ground could be, exposed or revealed in a way that creates a different spatial experience. These are, kind of larger study model collage pieces. And at this time I was kind of going back and forth again between like the digital underlay and the hand-drawn, of trying to understand what the expression of that, how that's helping you drive what the project is about. So these are kind of like big drawings of that. And yeah, and still always retaining a little bit of the digital. Okay, the last school project is my design thesis, and it started off with the premise of the idea of this social infrastructure. So how do you how do you design spaces that are sort of a collage of different program types, but are actually like a piece of social infrastructure that affords connectedness. So I didn't go in there thinking it would be at least a portion of an airport. It actually was, started off with hybridizing different program elements. So things like a power plant and a city hall and internet switching station would somehow be combined, and things that are, social pieces like the city hall would be paired with things like the internet backbone, which usually is not exposed to people in a way that kind of illustrates its physicality. Now, an airport is a perfect example of how that, that comes together in one location. You have a piece of social infrastructure like the airport terminal mixed with things that are unseen, like the airspace requirements, and and a big piece of physical infrastructure. So that was kind of the jumping off point. And so I looked at the Saarinen terminal at Dulles, and it ended up, kind of going in a lot of different directions and getting really weird. And it was, this is, just an image about looking at different scales of mobility, right? How do you, how are people movements mapped, and how is that relevant to someone flying from Dulles to any other location? And it became more and more like, let's zoom in further and further. And what, these drawings are just looking at, okay, if I look into an airport and there's the concourse tunnel that takes you from the Saarinen piece to an outfield concourse, that is in that length, you could accommodate all the airport program. And how does, hybridizing that program really start to reveal things? So these are just drawings that are talking about, what are the different space implications of the arrival sequence and the departure sequence, and how are they, what would, being able to, go through ticketing and see the customs hall, how are those two pressures put on each other, and how are you, how is that revealing an interesting architectural experience? So this is like, these are plans and a section of those conditions, and it ended up being an all subterranean architectural project, which is really weird. So these are just more graphics from it. One of the kind of interesting things that I took from this studio was the start of like a parametric design methodology that sort of didn't assume what the end product was going to be. I didn't know going into it that it was going to look like a weird, series of muscles or a slug. I went into it thinking, at the top of the image, it's the map of all those different spatial conditions, and the way that you bundle them and arrange them are important and spatially relevant. And then it resulted in something. So you could move each one of these little blobs around, and the overall form changed. And so, these are just sort of early studies of how that happens. And really simple things like, again, how are things putting pressure on each other, and how does that push an element out of the way? How does, when you smash these things against each other, pressure develop, and you start to create some new spaces. And this is actually just a physical manifestation of how can you design a module that is adaptable and that can change, and that, through the aggregation of those elements, it can form these tunnels that are burrowed through the earth. So just quick, physical model. Again, it was a dialogue between the physical. How am I modeling something like bundles of wire? And how is that digitally represented and then physically, represented? So after graduating, I worked, for a couple competitions with a group called Future Cities Lab. This is one from the Performing Arts Center competition in Seoul, and it was really sort of right after thesis, and my thesis advisors were like, "Listen, we got to do this in a competition, so let's take that same methodology and apply it to somewhat of a kind of a building program, a real building program." So this is using digital tools and physical tools to approximate this catenary structures, and then an image of the project on top. And the project was really starting looking at flows. The site was in the Han River. It was in the middle of the river flow. There were lots of cars crossing perpendicular. There were people moving around. And how do you pool those flows? How do you allow the the buildings to be informed by those flows. This is an early, like, just kind of, sketch of how you move the tower components. There were residential tower components with their like sun shadows, and you were trying to place these elements, but not necessarily determine the outcome. The outcome was, really a result of the relationships that existed between them. So there was a network that you defined that would be more important than necessarily the final arrangement. This is the final arrangement, and you can see how that makes an impact on as the traffic moves through and there's increased flow. Things like the structural web is sort of has to deform to accommodate that. And these are just some renderings of that. There's this. These are the performing arts kind of pods are hanging from the ceiling. And there was a constant going back and forth, marrying digital and physical. So in like 2005, I relocated back to Chicago and started working at Valeria DeWalt Train. And it's a really great experience coming right out of school. Joe has a pretty good program of like wanting to have some young people in the office working directly with him in a way that's you get to engage on projects that are the kind of speculative projects and sort of the best projects. So look at a couple here. This project was just one of these week-long speculative exercises, which were come up with an idea of what a new aquarium could be for Chicago in 100 years. So I started looking at like biological systems and how that might take over for like mechanical systems or technological systems. How we might grow building skins and building forms. So this is just some studies in how nature does that. And then locating a new aquarium, basically getting rid of the old shed building and looking at how the building can filter the water of Lake Michigan, how the experience of moving through the galleries and the habitats, which have very different space requirements, how those relationships actually are important and they put pressure on each other. And similarly, like how are the building elements in the skin, how are we harvesting energy and creating inhabitable envelopes. Just kind of fun views of that. This is another project from Valeria, which is a built project. It's for the Garmin flagship store on Michigan Avenue. And it was a small project, but again, given kind of a lot of design responsibility. And we started the project in April and had to be built in November. So it was the first kind of exposure that I had to like an extremely fast track project that with a lot of, with a lot of design into it. And so we very quickly iterated through a bunch of different options. This is like one of the early sketches for what the concept of the project was, which is like the idea of this smooth wall meeting, sort of a more refined aluminum wall. And it ended up being this sort of wrapper that encloses the store, and it has three-dimensional profiles that are very beautifully formed out of wood. And again, kind of using these tools to go back and forth. This is the 3D model view of it. But any one of these points you can kind of pull in and out, and it changes the global representation. And that was important because in coordinating with like the fabricators at Imperial Woodworking, they were very conscious of the limitations of the machine and the clearances and the tolerances that it could deal with, and actually how the guys were going to build it. So very quickly we could make modifications to our model and have them then take that, modify it for their requirements, and get that back and be able to overlay that and understand the implications. And that drove further development and refinement in our model. And this was the first time I had been kind of exposed to that digital fabrication workflow. These are some guys in the shop actually putting it together. So it's kind of interesting when you've done digital work or even non-digital work, but not built. And then this is the the result of those lines meeting the paper, or the mouse hitting the click. This is also the first project that I worked on that is now closed and converted into something else. So. Okay, so now you guys are all from ASGG, so you've seen a lot of this work before. But just kind of to make the connection to kind of current work, and this is some of the work that's now part of the submission. The Federation of Korean Industries is a project that we started in about 2009 in Seoul, Korea, and this is actually, weirdly enough, it's right inland from the earlier project that I showed from Future Cities Lab. So it was kind of coming around. It's a 50-story building here, and the portion that I worked on is this 3-story conference center. And the conference center is clad in this double curved glass facade, and the actual enclosed conference elements, which are just opaque by their nature, set off and within this the shell. And there was a challenge because obviously, if it's a double curved glass facade, it has, every formed panel is different, and that has a huge cost. And so early on in the process, we looked, right away at all of the panels being double curved and every one of them being unique. And then at the opposite end of the spectrum, every panel is flat, and I think you can see, there was a dialogue or a negotiation that had to happen to end somewhere in the middle with, approximating the design surface in a better way. And this was in collaboration with, at first, we were doing this all independently and kind of discussing this with the client. And then eventually the fabrication team got on board and they produced this model in the middle, which is, it's a mix of unique panels and non-unique panels. This is, just some shots during construction. You can see it was with Fulcra, was the fabricator working with Precursor, was the glass vendor. They're out of Spain. So you can see this is, it's a beautiful little jewel project that really kind of got to flex the skill of, starting to input some of these parameters within the model. So as you're designing, it's giving you that feedback in a live way. So then the second project is Wuhan Greenland Center. It's another project with ASGG. It was a competition that we had won, and this is an image actually of it under construction with like a Air Force performance team flying by. It's a project in Wuhan, China. It's just over 600 meters. And it was, the first real chance that I had at working at ASGG to work on a high-rise project that wasn't just a competition. It was now we're doing this project and the rubber is meeting the road, and we're really going to have to execute. So that same pace of during the competition, doing all these design iterations, all of a sudden went into, the creation of the building. It also was sort of my first look at how the structure of the building and how the architecture of the building has a real impact on the performance of the building, not just in a, how much energy is it generating, and how much energy is it conserving. In this case, we made a lot of architectural moves, like tapering the building, or rounding the top, softening the corners, and punching holes in it to reduce the structural loads on the building. And those were tested with RWDI as physical wind tunnel tests. And we went through, many iterations of that, to understand what the impact is of the architectural moves on the structural system. That has a huge impact on the embodied energy in the building. And if you can save 10 to 15% of the steel tonnage on a building of this scale, that has a much bigger impact in terms of the efficiency of the material use. And that, to me, we also didn't pull any stops with the architectural design. So that was just some kind of quick looks at the notch feature, and this is the top. This is kind of where it is right now under construction. So you can see these are just some diagrams of, it was very important that that all the while we were very conscious of how the structural system was married to the architecture and how that, was impacting the overall profile of the building. The program constantly kind of changed through schematic design, so it was kind of fun to keep that in order, and again all the while creating a very iconic building. And so we went through, this is early in schematic design. We went through, a huge amount of design options just to, for all different reasons, program. And it was aided by the fact that we were using sort of a parametric workflow. So this is an early, just network map again of the various forces that are at play. You can see things like the program, or in this case, we're starting to look at how there's the different panelization. So that script was actually our our digital model maker. We could understand what the program was, and we can understand at a very refined level, in this case fabrication, all at the same time. So every move that you were making to accommodate a different program from the client or a different requirement from the structural engineer, that had a different iteration, and you needed to respond with visual information. So the partners want to look at what does it do to, how does it change the profile if I move these notches in and out, or up and down, very quickly be able to turn that around. Understanding how the different analysis performance is doing. This is one look at how many unique panel types are there on this building, and we were very conscious of this, having just had the experience at FKI, to be able to kind of alert the client to how we can do this, and how as we were looking through this process again, how we were changing the building and what effect that had on it. And it was at it got to such a detailed level. You were understanding the curtain wall detailing, and you were trying to understand again these big global moves and how we were able to accommodate it. In the end, this is what you're kind of going for. It's not you could have any one of those steps said this is not our process, and I think you would end up with a much different building. Okay, so at that time, there was sort of a lot of disparate people within the office that had the skills and the tool set to do this. So this is, we started to look at having an in-house sort of learning, a learning group, or in these images, they're weekend hackathons. And these were a chance for people to work. At the time, it was you're supposed to not think about the project and not think about the day-to-day, but you'll see how it kind of unfolds. So people were looking at things like this was just simulation of fluid in the computer, and this person had no idea how to do some of that coding, or in this case visual fabrication, how you can unroll complex forms into flat printable surfaces. This guy was doing responsive facades, so this sort of form moved in and out. You can see how it sort of loosely applies to what we're doing day to day, but I'll show a couple examples of where it directly applied. This is just some wearable technology, and people who would normally not, they're working on architecture every day. How would you design a wearable object, and what would be the sort of the responsiveness? It like lit up in a way that was responding to how you were moving. I'm surprised, I was sort of really interested at the first couple to sort of map temperature, humidity, pressure within our spaces, and built this, what kind of looks like a bomb. But it was really to sort of understand that. I'm really surprised by people who are like, oh, this like measures it, and you can make changes to your environment. I'm like, that's what a thermostat does, but it's not crazy. And then also, I was really kind of interested again in this idea of like digital and physical things. So the these are just tools of how you can have physical devices that are shaping things in the digital world. So this is, on the right, it's Adrian saying, I kind of want the building to be about this high. And you can, the building is being built in the computer at that height. We ended up with like a proof of concept of a sort of a way of digitizing the physical model. We were taking a physical model and putting it in digital space and being able to reveal things in digital space that you couldn't get from the physical environment, right? I can understand relationships and scale with the physical model, but I maybe can't overlay what the effect of the radiation analysis is. We have a lot of fun doing some VR work in the firm, and this has actually been, this is several years old now. You'll see, this is the Astana project, but it was really like, a lot of it was. You're trying to imagine something that's at a much bigger scale than what, than the space that you're in, it led to, the kind of exploration of those ideas on a project here in Chicago. This is for the National Museum of Health and Medicine. This is a speculative project at the beginning. It was just for, rethink what kind of museum of the future is, but rethink it because the collection of this Chicago annex of the National Museum is all digital, right? They're digitizing things like, the microscope slides for the development of the polio vaccine. So how do you reveal that to people coming to a digital museum? And that manifests itself in a temporary exhibit in the space, which is on Washington LaSalle. This is the second project that's no longer there. So anyways, it was we were starting to look at just ideas of how you were able to interact with the exhibit. And again, the fact that it's an all digital exhibit gives you the chance to really interact with it in a way that you're not accustomed to. So these are Kinect sensors that are actually tracking individual users as they're walking around the space. So you could start the exhibit anywhere, and it's tracking you, and it's revealing more information to you as the longer you linger within the space, or can recognize gestures. So that was, the space is just a simple ring of those digital displays. And kind of the interesting code discussions we're talking about, what happens when two people are next to each other? Does the exhibit change as there's more people within the space? It was kind of fun. Okay, the Expo 2017 project is for a World Expo in Astana, Kazakhstan. This is the video, the launch video when we started, and this is probably one of the best videos of okay. So the project was a competition that was to develop the World Expo on this kind of greenfield site here. It's about 175 hectares, which is almost like the scale of the Louvre. So imagine that you're going to do this, and it was in like 2013. So it was 4 years before it was supposed to be built, late 2013. So we were this was fast track at a much grander scale. The inner circle is like the Expo portion, and it started and has ended. It was through the summer of 2017. So again, these were this was an opportunity on this project to really showcase, how we need to develop, the digital workflows to allow us to work at that pace. You were going from sketch to construction in a very short period of time, and that required you to just figure out how you were going to do it. And all the while, we were had very aspirational goals for performance. The title of the expo was Future Energy, and they were really committed to this idea. So early on in the project, we were doing big studies about how the whole site should be oriented, how the roof surfaces should be changed. To do the best we can in terms of making it passively, to basically grab as much as we can at this first 30%, bring down the energy usage by creating the buildings more efficient, and then do a little bit of, as much as we can, of on-site renewable. But even with that, you can see it's a third of what we can potentially save. And again, we were doing this using Rhino and Revit, and we worked on developing tools to let us do interoperability in a way that let us, again, be designing and sketching almost until we were issuing documents, which was, kind of on a monthly rotation. And it was, with a team of 60 plus people in our office and then a team of international consultants, all kind of working in that same model. The part that I'm going to focus on is the sort of sphere and this kind of associated ring around it. The sphere was sort of dictated. It's an 80-meter diameter sphere, and the president of Kazakhstan really wanted an iconic structure. So that during the competition, it was different. The sphere was sort of deformed to respond to the solar conditions. But in the end, we were working with the sphere, which was actually, it affords you a really unique structural opportunity in that the sphere is basically supported by the exoskeleton, or the exterior structure, and that rests on two piers that are the core of the building. And that was, that's very aspirational for a country that doesn't normally build with that technology. So you can see those two piers right here, but there's no columns, on any one of the floors. As you can imagine, like building an 80-meter diameter sphere is, it encloses a lot of area. So we were, the program area for this exhibit space was not that much, but it gave us the opportunity to create this pair of atriums that I'll talk a little bit more about. So, you basically can carve away the floor area to reduce the program area, and by the kind of twisting and morphing of that floor plate to respond to, say, on the atrium that's facing the south, terrace it towards the sun, it really creates this unique space. The other kind of iconic feature of this sphere is this pair of wind turbines up at the top. And early on in the process, we were looking at building augmented wind turbines and how, the shaping of the architecture is actually promoting that flow. So these are just, some early examples of how we've, formed that. Do you want to harvest wind at the edges? Do you want to kind of, harvest it at the middle? All these different iterations. And we went through that with our WTI, and they did this series of tests. And we learned a lot about how wind moves around buildings from this exercise. And, it was interesting, but the lesson learned is that, for the more aggressive turbines, they can absolutely recover more energy, but you're introducing much more surface area to the outside of the building. So the thought was just to put a larger pair at the very top of the building and shape those as best you can. And wind speeds, as they indicate, were upwards of 150% of what the normal wind speed would be. So the building was doing, its job. So these are just some further shots of the construction process. You can see these sort of, the north atrium and the shaping of the atrium edge, and how that, that it results in a very complicated steel structural system that is that we worked with structural engineers and reviewed the shop drawings for the steel, all digitally in 3D. This is as it's built. The other kind of unique feature that you're designing an all-glass sphere in an environment that has a huge temperature swing, even more so than Chicago. It can get down to minus 51 Celsius here, so it can get very cold, but the effect of the sun warming that space was cause enough for us to do a lot of investigation in terms of how it would be, how the glass is selected, how we're doing fritting, and in the original inception was to try to harvest as much energy as you could from the surface of the sphere. And all of that kind of went into an evaluation of what you were doing, overall. So again, all those different wind shaped buildings, how much wind energy were you generating, how much solar energy were you generating, but also how much more exterior envelope are you going to have to heat or cool, And those all kind of weigh into those choices. And again, this is not because you want it to look like this. It's because you don't want to presuppose the outcome. Okay. The other little piece that's kind of off to the side here is the Energy Hall. It's a 1,000-seat auditorium, and it was sort of like the FKI Conference Center was intended to be this kind of jewel box, and really through the activation of this and the articulation of that wall, be able to kind of engage the covered area that's next to it. So this is the built form of it, and this was born out of one of these hackathon projects. So we knew that we had to design kind of a very unique, but it could have been sort of a plain wall that similar to the FKI project. And how do you make it more engaging? And so we just over a weekend shredded out a couple of ideas about how maybe the wall moves a little bit, or maybe there's embedded LEDs. And we went in another hackathon went through the fabrication of some of these elements. Things that we didn't do before. We've never at that time didn't vacuum form cellular pieces like this and embed them with LEDs, and none of these people knew how to solder or code how to do it. And we created a mock-up in the office that really was compelling enough again for them to build the real thing. And it's really it's amazing that again that was a fruit of this process. Okay, last project, I promise. This is a project for the Mobility Pavilion for the Dubai Expo in 2020, and this is a project that really kind of ties some of these ideas together, and it really was like a strong team of people who were sort of embedded with that process. The theme of this particular pavilion was mobility, and an image that we kept on coming back to was these Bedouin tents that are from indigenous people in Dubai. But ideas of how rapidly this could be deployed, or how this is much more tuned to the environment because it can be able to open up a side when the prevailing winds are right. It's shaped in a way that is allowing for the heat to move through the building. It's very compact form. And these themes, were really impactful on what the project was going to be. And then from an aspirational level, we were trying to understand what mobility meant, right? Did that mean mobility? And what you might initially think is that because it's portable, that means mobility. But it was actually portable because they were trading. So all of a sudden you're talking about social mobility, or kind of a different layer of unseen factors that we really wanted to embed into the project. So we looked at how different scales of mobility. And we thought the other thing that we were trying to understand was how quickly could this be built, and in a way that allowed for sort of a long span structure to be built on site during the winter months when it's a habitable construction environment, and that allowed the workers to then populate the rest of the pavilion elements underneath. And just because I'm really interested in this idea of how natural systems do this. So how are natural systems changing their surface area to regulate things like temperature, humidity in the project? So we did these early sketch models, which were just how are we looking at things like long span shell structures. In this case, these blue balloons were actually the program elements. So there was two kind of disparate parts of the program that were wanted to butt up against each other and be really compact. And then how does the structure respond to that? And of course, developing digital ways of representing that and showing that. And in a live model so that you can actually start to, alter the program elements, or in this case, the entry of the building, I'm going to move that around for various reasons. And I want to understand what the manifest form of that is. And how that could also, change the shape of the skin, and how those investigations were really about, again, changing the surface area of the skin to have the building naturally ventilate itself, how you can generate energy on it. So this is the final submission. It ended up being a completely opaque, thin shell concrete structure, which gave you, thermal mass, and it allowed you to populate it with photovoltaics, and so that you could generate energy off the top of the surface. You can see those photovoltaics here. Then light is let in through the bottom, similar to the Bedouin tent. And it created these, really great interior courtyard spaces that allowed airflow to move up and through, and light into the interior spaces where, people were moving around. I got a fun thing about these ideas that we were looking at on the exterior. We started to look at on the interior. And so these, if you could imagine the ceiling being like a fabric surface that is somehow actuated or responsive to people who are moving around. So this group of people, the shape of the space could change in response to you kind of moving through it. Overview. So I just want to say with that, all of these, especially, as I've gone through my career, and especially in projects like this, I've gotten to work with a lot more and more people who are really engaged in this subject and have challenged me, day to day. So I think that at the beginning you saw projects that were, school projects that were about, a singular idea or, an engagement with a single critic. And in this case, this is just like every project at the SGG is born out of conversations and collaborations with a much bigger team. So with that, if you guys have any questions or want me to talk more about anything? Actually, that was the kind of hardest thing of this presentation. I think the work of the award submission was very easy to put together. It was already there, and we've talked about these projects, at length within our office. But it's, the kind of first part of understanding, well, how did you get to this point? It was, that was a much longer road for me. And, Joan asked me to do this a while ago, and I'm like, okay, we can, I'm going to really think about this. And then once you start digging into it, you're getting into kind of, starting to try to understand what those connections were. And you understand that, this is, as that factory is, it's a piece of social infrastructure that is talking about, the way that people are trying to use space, and in that way it was embedded in a neighborhood. And I hope this, these projects will also be considered that way. Thank you. I will say that it was not conscious going into this. You don't draw those connections or those conclusions going into it. But I'm glad that you guys were able to. Sure. You're like, who are you?
Fantastic work. I love the progression. But do you think, from where you started, now working with clients and programmatic elements, explorations, do you think you are able
I think that that is like, you know, it's partly personal and then partly like the people that you're working with. I think that I, I don't think it's more dogmatic that it's program and clients and realities. I think that there are new challenges that I think in the work you'll see that that it's we're trying to meet those challenges with as innovative a solution as the original design idea, right? If we would have at any point said, you know what, we don't want to have the conversation about double curved glass, we wouldn't have been able to execute it in its final form. And I don't know that it would have ever gone down that windy road without that drive. And I don't think that that's just me. I think that is the firm. I think that people are really, if you're driven to do that, I hope the outcome in every one of those challenges is as engaging. What's that? We are. I think that the way that we are, it's not in I think in a format that we were originally doing it. And I will say the challenge for someone like me who was trying to, the reason that we did it was so that we can start to engage people in the office in a way that's not, the day-to-day I'm drawing, whatever part of the building that they're drawing, to try to break it out, because ideas like these won't come out of, being sort of worn down by that. I think that, so to do that, I think that where the hackathons have gone is less of like a learning, hey, I'm going to try to teach people how to solder LEDs in a more like sort of collaborative learning. Like we need to all go on a journey together. I can't, we don't want to have it be a case of either everybody is sort of learning at their own, in their own places, or, in the case of like the Astana energy wall, that was a case where all of a sudden it clicked because we were, there was 4 people working on that project, and we were all really, really into it and learning together. And I think that that's what we're trying to do now is this idea of learning together. That's a good question too, because I think it does need some fresh people. So I think that we've been talking about how do you engage. Our structural engineers are always asking us, when are you doing another one, and when can we come? So it's something that it's on our mind, because I think that, again, we're challenging each other, but especially at SGG, you have exposure to, the best structural teams, the best wind engineers, the best mechanical engineers, and how do you engage them in this process so that, how are you pushing it forward? Yep.
While some of the forms were really derived from kind of more inspired from the local context, how could this digital, program parametric design can be applied to, vernacular materials and local indigenous, climates and things of that nature? I mean, how can kind of any ordinary people, with the I'm thinking more so also about social aspect, about how can we really apply that kind of thinking, analytical thinking into the context of the vernacular community. How can we marry those and, not just create something that's beautiful, but makes it foreign to a certain context. And obviously, these were had a specific program, but how can we go to the next step in those?
I'll say 2 things. I do think that all of the things that we used sort of technology for were not about the eventual aesthetic, right? I think that um, you know, again, we didn't presuppose the outcome in this case, but we were like really into what the process was. So we knew, you know, so I think that when you do that, that allows you to have, the environmental analysis or the original, the box where we're moving the pieces around. That was really designed for like a local project with the thinking that like you were engaging things, again, not aesthetic, but they were like proximity to other elements. What happens if I move this piece closer to here, move these things around. So I think that with that, you're using the technology to kind of reveal things that are unseen. In some cases it's environmental, in some cases it's physical proximities that you're somehow trying to respond to. And I think that is the part that I hope is evident in the work versus any sort of the second thing I was going to say was the design aesthetic. I hope that you don't look at it and say, oh, that's a building that XYZ designed. It really should be born out of the fact that it's deeper than that, and it's about if you see anything from it, from those variables, like, oh, well, why is it like that? And you should be able to point to something that says that's why. So I think that transcends the stylistic stuff. I will say yeah, I mean, it's immediately apparent and revealing to me. I mean, it's something that I know exists, and I've known it to exist, from the first time I started to work at ASGG. Actually, was the, even at Valerio, I was still, there was a small team, right? It was still a dialogue between a couple people, and all of a sudden, at ASGG, it was, you're on a team with 30 people. How do you even, that sort of, and everybody is at the top of their game, including consultants. And I think that to me it's revealing that these types of projects, or the projects that I'm really interested in, are like a collection. And so I hope that that is evident. And then the other thing that's evident is that it's not necessarily, I think the product then is a result of all of those contributions. It's not a question of like authorship. It's more a question of I can't do this level of work with it as just one person. It needs the resources and the talent and the collective. This is the sum of this sum is greater than any one of the parts. And I hope that at least speaks to how I have gone from mentee or student to team leader, is that the style of working that I think is most appropriate and the best way to solicit these types of ideas from people is a true team collaborative environment, and not a top-down approach where you know what the solution is. It's born of, hey, we know what the conditions are, and we're not going to presuppose the outcome, and the end will be beautiful just by its nature, because we are all sophisticated designers. We're going to make it beautiful, but it needs to be more than that. It needs to be embedded with the things that the team collective puts together.
Talk a lot about how you're trying to like design and build things, and you don't presuppose the outcome. All of it's you try to derive its form.
Mhm.
Its most true essence from the environment it is in. And then you also talk about architecture as a platform for social engagement.
That is a fluffy question. I hope that it creates an engagement, right? I think that if you are challenging the built environment, and I think the best critics for the built environment are people who are not architects. So if you're challenging the built environment, including the place that we all live, if you're challenging it and asking it to do more, then I hope that the projects that I've shown have at least talked about what's more, what could be more. And it doesn't take, you are going to design a building anyway. So I think embedding the challenge of, what more can it be? How much better can that perform? And that's a loose term, right? It doesn't necessarily have to be about, the wall assembly materials. It needs to be, a broader question about how is it allowing for engagement in the community, people to understand what it is. Why are they interested in an energy performing building, high performance energy conscious building? Why do they care that the steel is structural steel is reduced in a building? Well, they should care because that transforms the environment in a way that's maybe not real. Because it's architecture. I think that, like, at least being on reviews and being engaged with academia has shown me that they absolutely have the tools to do it. Students coming out have now in themselves they have the tools. Right? I don't know that maybe they aren't engaged at the academic level, but I do think that, like, they have the ability to use all the technology, or they're at least exposed to it. If I was exposed to it in 1985, then they absolutely. What I'm trying to think of, like, what if you have all this access, how do you transform the next environment? Thanks, everyone.